Hey guys, in this video we'll learn about limits and continuity. So first of all, what is the limit? Well, in general, the limit of a function is the y value that a function approaches. Continuity, simply put, is a function you can draw in one singular motion without having to lift up your pencil. So the first thing to remember is whenever you see a function like this, the limit of f of x as x approaches a equal to a. It means that when the x value approaches a, the limit of f of x is equal to a, which is the y value.
To start, we're going to talk about the formal definition of continuity. There are three conditions that have to be fulfilled for a function to be continuous. The first condition is that the limit of a function, f of x, as x approaches a point, c, has to exist on both sides. So in this case, if I draw a graph, the limit from one side on the negative side has to be the same as the positive side for the limit to exist. The second condition is that the point f of c has to exist. So f of c has to exist. So for example, if you have a function with a hole at c, that function will not be continuous because f of c does not exist. And the third condition is that f of c has to equal the total limit of f of x as x goes towards c. So if you have a function like this and a point right here, that would not be continuous because f of c does not equal the limit. And for a function to be continuous, all three of these conditions have to be fulfilled, and action.
All right, so now we're going to talk about limits. So for limits, when x will be approaching infinity on the bottom, there are three examples of what can happen when you have, for example, 2x to the third over x to the third. When the exponents are equal on this, you just cancel out these exponents. These don't matter for you. And the front number in front of x to the third will be 1. And you just take the top number and the bottom number for your biggest exponents. So it'd be 2 over 1, which equals 2. So limit as x approaches infinity for this function would equal 2. And then for a second example, as x approaches infinity, let's say the bottom exponent is the larger one, x to the fourth over x to the fifth. 5 is larger than 4, so then the limit for this function has to approach 0. So limit as x approaches 0, as x approaches infinity for this function would equal 0. And then for our final limit, as x approaches infinity, we'll say the top exponent is bigger. So let's say x to the fifth over x to the fourth in this case. So the top number is going to be, as you approach infinity, the top number is going to be increasing. It's going to be larger and larger and larger. So then you know that this limit has to be infinity. Now we're going to show functions with limits that are not infinity. So let's start with a simple one, as limit as, let's say, x approaches 2. For a simple function like x squared minus 4 over x squared. So you're just going to plug your number in for this one. So it's going to be 2 squared minus 4 over 2 squared. So then you're going to have 4 minus 4 on the top over 4. So it's going to be 0 divided by 4, which is just going to equal 0. So a simple function, right? And then we're going to go, let's do a more difficult one. Let's say x approaches 2 like so. And then we're going to say x squared minus 3x minus 28 over x squared minus 6x minus 7. So it's a little more complex function, but this function can be simplified if you factor. Let's say x minus 7, and then x was 4 on the top for that function. And then x minus 7 and x plus 1. And of course you can factor it using rules, but we're just going to skip that part for this one. So then x minus 7 will cancel out on both the top and the bottom. So you're left with x plus 4 over x plus 1. And then you can just plug your number in. So it's going to be 2 plus 4 over 2 plus 1. So you're going to get 6 over 3, which will equal 2. And then for
Alright, so I hope you guys learned about limits and continuity in this video. Just to review, a limit is basically when the y value when a function approaches a certain x value. So in this case, the limit as the function approaches c would be the y value here. And then continuity is basically just if you can draw the whole function without lifting your pencil up.